Hello everybody, today we're going to be going over a logic problem at the IB Math Studies level. So, they tell us that popularized on the internet, fun names are often given for different types of dogs. 3 of these names are given in the following propositions. So we have P, Q, and R. Part A tells us to write down in words the compound proposition P implies not R, okay? And for these problems, you can do it very methodologically, if that's a word. But whatever, there's like a super clear method that always works. The implication, we're gonna relate it to the words if, then. Okay? This guy right here is going to be and. Of course, we're not going to use all of these in the problem, but this is really all you need for logic. I mean, for most problems, this is going to be like a, I don't know, if you have this in your mind, you can answer parts A, all parts A of logic problems very easily, and they're worth 2 points, so it's worth having it memorized. So, to write down in words the compound proposition P implies not R, alright, and I forgot this one, sorry. This guy is going to be not. Okay? So for part A, writing down in words the compound proposition, I'm turning all of these symbols into words right here on the top graph. We have if P, then not R. Okay? Of course, this is not complete because I have to plug in P and plug in R. But as a first intuition, this is going to be the answer. Okay? So plugging it in, if it is not a doggo, then it is not a woofer. Okay? I highly suggest that you do this step first because once you plug in P and R, like it turns into a super long sentence and like P has a knot, but it's not naturally a knot. I mean, it doesn't have a knot in front of it. It can get confusing. Okay, so first define it like this and then plug in. Okay, the P is seen here and the R is seen here. Okay, of course, the if is this if, the then is this then, and the not, well, you have to make it sound pretty, so it's going to be in between the R, okay? So that is part A. Okay, for part B, we have to write down in symbolic form the converse of this whole chunk, okay? P implies not Q and R. So before getting into it, in logic, we're going to have 3 things. We have the converse, the inverse, and the contrapositive, okay? And unfortunately, you pretty much just have to remember these, okay? Let's imagine that we have P implies Q, okay? For the converse of this, you're literally just going to flip it, okay? It's going to be Q implies P, right? So this first one, you just flip. For the inverse, however, you're going to add a not to both sides. So it's going to be not P implies not Q. So here's just like the not on both sides. Okay? This is the first one, this is the second one. And for the contrapositive, it is going to be not Q implies not P. So what happened here? Well, it is the first one and the second one. We flipped it because Q is in the beginning now, and we added a not to both sides. Right? Unfortunately, I don't think there's a very clear way to remember these words intuitively, so you kind of have to memorize it. The only trick I used to do was that inverse is going to be like opposite, so it has to be adding the not. And I also remembered that the super long word is going to be one with more steps, right? It's going to be 1 and 2. So if I remember 2 of the 3, the third one is the one that's left. So that was a trick I used to do. You can find your own way. So now, in symbolic form, we have to write down the converse of P implies not Q and R. So if we have this guy right here, and we know that the converse is literally just going to be flipping the 2, this is going to turn into not Q and R implies P. So that is our answer for part B. Okay, and now for part C, we have to complete the following truth table, right? And so they give us all these values, thankfully, and we just had to find these 2 big chunks, okay? Now, I know this can be overwhelming, so you always want to go from left to right, okay? And you want to go one file at a time. The only values we care about in this scenario are, for this whole chunk to be true, both sides have to be true, okay? And the only column we're going to be looking at are these 2 right here, okay? I know the data can be overwhelming because there's a lot of columns and stuff, but you really need to focus only on the ones that matter, which are almost always going to be only 3, okay? So it's going to be this one, and this one, right? So when 1 and 2 are T, that means 3 is going to be T. Okay, so that is the relation of the AND. If they're both true, then the whole thing is true. If one of them is false, the whole thing is false, period. So for the first one, we have 2 T's. So that makes a true for the third point. For the next one, we have 1 false, so it's going to be false. For the next one, we also have 1 false, so it's going to be false again. Another false, false again. Here, we have both true, so it's going to be true. Here there's 1 false, so it's going to be another false. And down here, they're both true. Okay? So that is the chunk of 3. Now doing the final chunk, we're going to have the 3 and the 4. Okay? I'm going to define 4 as this guy. Okay? So the only ones that we care about now are these guys right here. Okay? In all these logic problems, you're always going to be looking like at 3 different columns, or so to say. Okay? And let's remember that this one is third. We have defined it. Okay? And this whole thing is 5. Okay? So, what joins both of these statements, the 3 and the 4, is this sign. Okay? Let's remember that this sign is or, but not both. Okay? So, at least one of them has to be true, but if they're both true, the statement is going to be false. So, looking at the columns 3 and 4, here we have 2 T's, so this is going to be false. Here they're both false, so it's going to be false. Here we have at least one of them is true, and the other one's false, so it's going to be true. Here on the 4th row, they are both false, so it's going to be false. 5th row, they are both true, so it's going to be false. 6th row, at least one of them is true and the other one's false, so it's going to be true. And the last 2 rows, they are both true, therefore the statement goes to false. Okay? That is part C. Finally, for part D, we need to justify why this whole chunk is not a logical contradiction. Okay? And this whole chunk right here is really number 5. Okay? So why is it not a logical contradiction? Well, because there are some true values, okay? It is true that there are a lot of false values, but we have to look at the statement as a whole, right? If, let's imagine a similar problem where all the values are true, okay? This is going to be called a tautology, okay? It's just a really fancy way to say it's true. If in a similar example, we have that all of them are actually false, we're going to end up with a contradiction, okay? Because the statement contradicts itself because it's all false. However, this is not a logical contradiction because in between the statement, some of them are true, okay? So for this one, you would have to call it something else. You would call it something like uncertain, perhaps, okay? An explanation to get full credit is by saying not all values are false. And well, if you want to get specific, you can always say that the third and sixth row are false. Okay? So that is part D. Now, I know that these problems can be like kind of confusing because there's like a table in between and it's hard to like define it properly or look at it properly. So what I suggest, especially for part C, which is the classic, is that you define it into chunks, right? What you want to do is 3, right? Is this whole statement. And we can cut it down into parts where this one is 1, as we had defined way earlier, and this one is 2, okay? And so within this chunk, the only thing that really matters, or what defines the statement, is this AND value right here, okay? And you want to get familiar with how these values work, okay? AND is going to be, they both happen to be true, this is going to be OR, this is going to be OR but not both, etc. Okay, and you can always compare it to the formula booklet. But I guess my key tip is like these long chunks, you want to split them into parts, okay? And always make sure that you're looking at only 3 columns. All these problems, you will always look at maximum 3 columns. 2 that you're comparing, and 3rd that you're filling in, okay? Well, that's the problem, and I hope it helped.